So, good morning, guys, and welcome back. I hope you had a wonderful weekend. And today we are going to discuss about two things. One is called the mathematical language that you can use while you guys communicate each other in a math session, or you can use the same kind of statements when you are communicating with your friends, with your peers in classroom. It's kind of a nice language. And the second thing is our topic under discussion, that is margin of error. The margin of error means it is kind of an error that we can find through our calculation, and based on that error we can predict something. Okay, so these are the two things we are going to discuss today. But before that, I just want to just go through the routine. So as per our routine, today we have the brain teaser. This is kind of a kind of an easy brain teaser. I can give you 3 minutes time to think on this, and please come up with your findings. That's it, your findings. Okay. So here it is. So please, I'm actually not going to send you guys to a breakout room because the number is very less for more breakout rooms. So you can discuss directly here in this platform, or you can discuss through chat, or you can have individual thinking time. But I can give you 3 minutes. 10:56 will be the time that I will call you back. Okay, there are four numbers. One is not belongs to this group. You have to find which one is that. Three minutes to discuss, or 3 minutes to think, or 3 minutes to communicate. Whatever you are thinking, you can do within this 3 minutes. There are four numbers. One number is actually not part of that group. Interesting. What number is that? You have 2 more minutes. One more minute. If you already have a solution with you, please type it in the chat window, but don't press enter. Yes, time up. Please shoot your answers or findings. I have one from Aiden. Aiden is saying that it is 36. I like your answer, Aiden. Can you please justify your answer? Can you please explain why? That's
Yeah. So why I think it's 36 is it's the only even number there.
Oh, that is a good finding. That's the only even number. Great. Okay, we can ask to um, Isaiah. Isaiah, what is your finding?
I I'm sorry. I think it is well. Uh, one is the only one that isn't a multiple of 9.
Oh, one is another answer because the others are the multiples of 9. This is not a multiple of 9. Oh, that is interesting. Okay, now we can ask to Jeremiah. Jeremiah, what is your answer?
I got the same thing as them.
Pardon?
I got the same thing as them.
Okay, you are actually agreeing with Jeremiah, sorry, Isaiah or Ashlyn. Ashlyn is also said it is one. Probably her justification also the same. Ashlyn? Okay, so we can go and ask to Louis. Louis, what is your finding?
45.
45. Oh, interesting. A new answer. What is? Why that's 45?
Because it's the only number that 5 goes into.
Ah, that's the only number. That's a multiple of 5. This is the only number that is a multiple of 5. Interesting. Robert, what is your finding?
That the bottom two are double digit and the top ones are single.
Oh, yeah, that I agree. But our question is which one doesn't belong? That means we need just one answer.
I'm thinking the even number.
That means this one?
Yeah, 36.
Okay. Javen, are you agreeing with Robert or do you have a different opinion?
I agree.
Agreeing. Josiah, how are you?
I'm good. How are you?
I'm pretty good, Josiah. Thank you for joining with me today. So, what is your opinion about this brain teaser?
I don't know. I got what Aiden got.
Pardon?
I got what Aiden got.
Okay. Who else we have? Okay. So I believe I asked everyone because Ashlyn is actually said one. So I actually don't miss Ashlyn. Okay, guys. So all these answers are right. One is correct because that is the only one number that is a multiple, that is not a multiple of 9. The remaining are the multiples of 9. 36 is correct because that is the only even number. 45 is correct because that is the only multiple of 5. Yeah, remaining are actually not multiple of 5. And 36 we can say because that is the only perfect square number. Okay, so these all are answers of this particular question. That means we have multiple solutions for this particular question. Okay, guys, thank you very much for participating in that brain teaser. And okay, so that is a nice brain teaser. It is actually gave us some kind of a brain exercise. Interesting. So now we can move on to a topic that is very new, and that is la 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 la. Yes, the margin of error. Guys, all of you, please turn on your camera. I can let you guys to turn it off. The one who is present here, no need to turn it on. But the one who is doing online, please turn it on. Jeremiah, Isaiah, Josiah, Robert is already turned it on. Javan. Thank you, Josiah. I say, can you hear me?
Yes.
You? Jeremiah, can you hear me? I hope you can hear me. If so, please turn it on. Okay, thank you all. So today we are going to discuss something called margin of error. This is kind of a very, very interesting and very useful item, this calculation. If we know this calculation, we can easily predict something. We can easily predict, say for example, usually these things of calculation, the statisticians using these kind of calculations for the election results, the results of a particular examination, the result of a particular school. So those kind of competition results, they can predict in advance using this margin of error. That is actually the very common usage that we all are familiar with. This is actually also using for some kind of prediction tool. So this is kind of a very useful tool in future for you guys also. So what is this margin of error? It is actually a statistic expressing the amount of random sampling error in the result of a survey. So if we are conducting a survey, whatever it may be the subject, if you are conducting the survey, this margin of error is actually representing the amount of error, the amount of random sampling error. Say for example, if you are conducting a survey, we are collecting some kind of data. So basically what we need to do is, what we are doing is we are collecting data, but there are chances for errors. So those kind of errors we can find it out or figure out using the name called or the tool called margin of error. Okay, so how can we do that? That is the question. 1 minute. Okay, so how can we calculate it? That is the question. So to calculate the margin of error, we have an equation. So margin of error, MOE. Okay, margin of error. This letter is gamma. Margin of error gamma. Gamma is actually the confidence level. How confident you are on this error? How confident you are on this survey? Okay, so the confidence level is equal to margin of error on this confidence level gamma is equal to Z gamma times square root of sigma square over n. Guys, I know that you guys are, what, Mr. M? Equations? No, we cannot do this. So don't think like that. This is just an equation, each term representing something. From your data, you can write or you can figure out what each term for that particular data. Okay, I can explain what each term represents. Okay, let me change the color of my pen. This gamma is actually represents, so you have to read this as not r. This is not lowercase r, this is gamma. Okay, this represents the confidence level. You will get an idea when I am doing one problem. This represents the confidence level, and ZR represents the quantile, I can explain what is this means. And sigma represents the standard deviation, and n represents the sample space. What? We have a lot. Mr. M, can you please stop this? Is that the feeling that you have now? Isaiah? Are you having that feeling, Isaiah, now?
Yeah.
Mac, what do you feel? What do you feel, Mac? Are you feeling tired because of these equations?
Yeah.
This is kind of an easy equation, but you have to figure out. I am actually not asking you to memorize it, you practice it, then it will be very easy. To get the margin of error, you have to multiply the quantile with the square root of the quotient of standard deviation and sample space. That is what is called the margin of error. The product of the quantile and the square root of the quotient of standard deviation and the sample space. That is margin of error. Okay. So I don't think you heard this term quantile before. Probably the sample space we discussed in class itself. We discussed standard deviation in class itself. We discussed this confidence level before, but this confidence level has no relation with confidence interval. That is something different. And this term quantile is somewhat new for you guys. Have you ever heard about this term quantile before, Isaiah?
No.
Okay, so this is kind of a new term. Okay, we can discuss what is that. As I told you, quantile is kind of a particular number that you can figure out from the data. Okay, in statistics and probability, the quantiles are cut points dividing the range of probability distribution. You may have some kind of a data, and these quantiles are the points, the cut points that is actually dividing the range of probability distribution into continuous interval with equal probabilities. So that is kind of a definition, but I can explain you with a problem that will make more sense. But before I start explaining that kind of a problem, let me explain the steps that you can use for finding these quantiles. Okay, so I believe if you can note this down, that will be helpful for you guys for the future problems. So suppose we have a collection of data. To calculate the quantiles, the step one is order the data from least to greatest. Okay, then step two is count how many observations you have in your data set. I believe if you can note this down, that will help you for future problems. And step three, convert any percentages. Convert any percentages to decimal for the letter Q. I can explain what is this Q stands for. And in step 4 itself, you'll get an idea what is that Q represents. In step 4, insert your values in the equation. We are actually looking for the cut value or the value that can cut the distribution into pieces with equal probabilities. We are actually searching for that. So that we are assuming the ith value of the observation is that cut value. So we need to figure out that ith value. That ith value is the quantile. So the ith value is equal to Q into n plus 1. So Q into n plus 1 is actually the quantile value or the ith value. Okay, the ith value. So you need to know what is this Q. Q is here. Okay, you may have a percentage mentioned in the question. That percentage you convert it into decimal. That value represents the Q. And n represents the in step 2 you are counting how many observations you have in your data. That number of observations represents n. How many? That how many is representing n. So that n represents the number of observation. So you can replace with that value. And Q represents the percentages to decimal. So you can plug that value here. So Q into n plus 1 represents the quantile of the data. So I hope you already took a screenshot of these steps: step 1, step 2, step 3, and step 4. If you already have a screenshot, please raise your hand. Use your expression button in Zoom. Yes, Mac is done. What about Javan, Isaiah, Aiden, Louis, Ashlyn? So Ashlyn is already have this. What about Louis? Robert? You got it? Aiden? Aiden, do you have a screenshot?
Yes.
Okay. What about Isaiah?
Yes.
That is great. So guys, now we can go back to our actual problem or actual assignment. So this is the assignment. This is the assignment. Student activity, margin of error. This is the very new assignment that I posted yesterday. So the questions are here. So the thing is, I'll actually explain this problem, and I will try to give you the maximum kind of evidences or maximum kind of explanation for each problem. But we have time limitations. So anyway, at the end of this session, you will have an idea what you need to do for this assignment. Okay. So the question, Lois, can you please read the question, the introductory part?
Differences may contribute to epilepsy results indicated that the selected group has significantly lower levels of copper ion compared to the non-epileptic group.
Okay, Lois. So the question was this. Scientists in Turkey undertook a study of people with epilepsy. The research included analyzing scalp hair samples from 22 participants with epilepsy and 23 participants without epilepsy. Interesting. So the study happens for 22 with epilepsy and 23 without epilepsy. Checking for differences in levels of copper, iron, zinc, magnesium, and calcium. Very nice study. The researchers speculate that such differences could indicate metabolic differences that may contribute to epilepsy. Results indicated that the epileptic group had significantly lower levels of copper iron compared to the non-epileptic group. The data can be written in tabular form as follows. Males with epileptic, males non-epileptic, females epileptic, females non-epileptic. Okay, so we have 4 items. Male, even though this is for male and female, we can again divide male into 2, that is epileptic and non-epileptic. Female also into 2, epileptic and non-epileptic. Okay. So if we can draw a tree diagram, we can draw like this. This is male and this is female. We can divide again male into 2, that is epileptic non-epileptic female also into 2, epileptic and non-epileptic. Even though it is not related to this epileptic, okay. Even though this tree diagram is actually not related to this problem, that is actually a previous knowledge we have from our classroom discussion. So we just applied it. There is no relation there for drawing a tree diagram for this problem. Okay, the data can be written in a tabular form as follows: copper, zinc, iron, magnesium, and calcium. Okay, what is the question? If it were possible to measure the presence of copper in the hair of all males with epilepsy in the world, do you think the average would be exactly 14 mu G by G? That mu G by G is actually micrograms per gram. Mu G by G represents micrograms per gram. Okay, so if we are thinking about copper, okay, so copper is 14 mu G per G means copper is present there in each gram of, okay, each gram of the item that we are studying. Okay, question is this: if it were possible to measure the presence of copper in the hair of all males, do we have anything which is mentioning about hair? That is the question. And if it is, question is, if it were possible to measure the presence of copper, so we have the study about copper here. Yes, we have the study about copper here. Presence of copper in the hair of all males. So this is male. This is also male. Males with epilepsy. Males with epilepsy is here. Just 14. Okay. Do you think the average would be exactly 14 mu G by G? Interesting question. But we can see that something is missing, right? But we can read the question once again. Scientists in Turkey undertook a study of people with epilepsy. The research included analyzing scalp hair samples. Scalp hair samples they studied. Oh, interesting. We have the information here. Scalp hair samples from 22 participants with epilepsy and 23 participants without epilepsy. Now we can go back to our question. If it were possible to measure the presence of copper in the hair of all males with epilepsy, all males with epilepsy is this, copper presence is 14. Then question, if it were possible to measure the presence of copper in the hair of all males with epilepsy in the world, do you think the average would be exactly 14 mu g by g? And explain your thinking. That means if you are thinking that 14 is the average, you have to justify why that 14. Okay. So how can we justify that? So we can believe 14 is fairly close, or 14 is okay, or 14 is exactly the real value. So we because there is a diplomatic way of writing that answer. You can say that we can believe that 14 is fairly close. That is a diplomatic way. We are actually not stressing. While others or some other students can think that it could vary widely due to other factors, especially if they remember the small sample space, 22 with epilepsy and 23 without epilepsy. Okay. But from the given data, we can actually go ahead with the data that they are collected or that they are researching on. So with the given data, we can say that, oh, okay, 14 is a fairly close item. So you can conclude that question number 1 like that. And what is question number 2? Isaiah, can you please read question number 2?
What did you say?
Can you please read question number 2?
Hang on. It says the journal article that contains the results of study actually reports that males with epilepsy have an average of 14 plus or minus 9, whatever that is, of copper in their scalp hair. What do you think 14 plus or minus 9 means in this situation?
Interesting question. Again, the question is about the male with epilepsy, correct? The males with epilepsy. Males with epilepsy. Okay. The question is, the journal article contains the result of a study actually reports that males with epilepsy have an average of 14 plus or minus 9. 14 plus or minus 9 mu g per g. Mu g per g is microgram per grams. Micrograms per grams, okay? Per grams of copper. Okay. So, question is this, what do you think this plus or minus 9 means? 14 is kind of a fairly close value because we already justified that in question number 1. And what is this plus or minus 9 represents in this situation? That is very interesting. Guys, these kind of studies, researches, you can see regularly in a lot of real world situations. So just try to figure out what is this plus or minus 9 represents. But any suggestion for that? Anybody? Any suggestion for that plus or minus 9? Usually when we are driving in highways, a pretty decent driver will look into the speed directions, correct? So the maximum speed limit they will take care of. But some persons will say that plus 10 or minus 10 will be fine. Okay, the cops will not catch us. So that's actually, probably that may be true, I don't know. But I'm always driving with the original speed. Okay, so there they are using the term plus or minus 10, plus 10 or minus 10. Say for example, if the maximum speed is 75, 85 is okay, but that is not the actual value. And you can drive in just above 75 also. That is kind of a belief. That is actually not a rule. So what is that plus 10 or minus 10 represents? That is actually a correction amount, correct? It is actually converging. That is an acceptable value. So in statistics, we will call that value as the margin of error. We are actually doing the margin of error topic. So here it is specifically they ask a question, what is that plus or minus represents? So the value can be either 14 plus 9, that is 14 plus 9 is 23, and it can be 14 minus 9, 14 minus 9, it is 5. So will that be the actual value? No, no, that is only chances. We have more accurate values, but when we are saying, okay, the value can be either plus 9 or minus 9. So we will name that adjustment value as the margin of error. Okay, the margin is 9 here in this question. So the margin of error, it can be. We will not accept the values which is below 5 or above 23. In between all values we will accept for the calculation purpose. So keep it in mind that those kind of values are called the margin of error. Okay. So next time when you guys are communicating or speaking with your friends, when you are driving, if they are saying plus 10 or minus 10 is fine, so you can change that word plus 10 or minus 10 into a new word called margin of error. Okay, we can have a margin of error of what's the meaning of that? Either plus 10 or minus 10. Is that clear? Is that a new terminology that you received? Margin of error. Okay. Okay. So that is about question number 2. And question number 3 is the plus or minus 9 is called the margin of error. That is actually a long question. Mac, can you please read that question?
Which number again?
Question number 3.
3? Okay.
Yep.
The plus or minus 9 is called the margin of error. This wording, however, does not mean that someone messed up the research. It simply means that no sampling method can guarantee that the sample exactly matches the population by the sampling techniques when used correctly. Can be trusted to give results that are according or accurate within a certain range.
Okay, okay, Mark. So the plus or minus 9 called the margin of error, and it is specifically saying that this is actually not giving us a guarantee that the sample exactly matches the population. Okay, and the sampling technique can be trusted to give results that are accurate within a certain range. So we cannot actually believe this is just survey or see after elections a lot of news channels will conduct a survey and they will call it as exit polls. So sometimes the exit polls will win or it will become true after the results come out. Sometimes it will become kind of a utter failure because the margin of error is not working. The margin of error they actually use from a survey samples. The survey samples will not behave sometimes so that their exit poll results will kind of a failure most of the time. Okay. So Javen, can you please read the remaining part? Javen, are you there? Javen? One more time. Javen? Robert, can you please read the remaining part?
Huh?
Can you please read the remaining part of the question?
Remaining from
So Mac read the first paragraph. You have to read the remaining.
since
Yep, go ahead.
Since the males with epilepsy in the sample showed an average of 14 UG uh, of copper in their scalp hair, the researchers are fairly confident that the true average copper concentration for all males with epilepsy in the study is between 5 and 23 UGs. Have you ever seen a news report that mentions margin of error? What was the report about?
Yes, that is a question that is actually not related to some kind of calculation. That is related to your what real world connections. Have you ever seen or have you ever heard this word margin of error? Or if you have seen, or if you just notice something which is related to margin of error, what was the report about? Okay, so you have to write your answer in that way, and you may have different answers for this. Okay, so that is the first three questions and its answers, and the remaining part of this assignment we will discuss tomorrow. I know that this is because this is very new, this will be difficult for you, but it is manageable if you are trying. Okay, because this is new, kind of, Mr. M, we never heard these words. Why you are giving this kind of assignments, Mr. M? So guys, all time, we don't expect something which is very familiar to you. Okay, you will face something unfamiliar situations in your life. Am I correct? Always you will not get familiar situations like that. You are actually getting some kind of unfamiliar situations. Please try to find a solution for that. Okay, so guys, thank you very much for joining with me today, and we can see you guys tomorrow. Bye.